Hey everyone. So, today I was going to go over net ionic equations. This is going to be kind of our first look into chemical reactions. And this is a pretty nice and easy way of kind of sliding into this. So, we're going to look at net ionic equations. This is going to be obviously ionic. We're going to be doing ionic things. And so, let's say we have a situation. We're going to pour two solutions together. Okay, we're going to have a solution of potassium chromate and barium nitrate. Okay, these two things, K2CrO4 and BaNO3 2. Now, remember, these guys are aqueous, which means that these are salts that are dissolved in water. Okay, and just kind of as a quick reminder, this side is going to be our reactants. We have the yields arrow pointing this way, and then products are going to be here. Now, like I said, you probably have noticed, no products currently in this reaction. We don't have products shown here. We're going to predict these products. That is going to be one thing we're doing. We're going to add these two solutions together. What is going to happen? Okay. So, first off, is there a better way of writing this? So this is in solution, right? What happens whenever you dissolve a salt in water? Well, those two ions, the cation ions and the anions, will separate. The potassium ions are going to separate, and the chromate ions are going to separate as well. The barium ions are going to separate, and the nitrate ions are going to separate. So you're going to end up with something that looks like this. This is another way of writing these things out. So you're going to have some two potassium ions in aqueous state. They're dissolved. There's two of them because it's K2 chromate. Okay? One chromate with a 2- charge, barium with a 2+ charge, and two nitrates. All right. So since this is another way of writing this out, now you can kind of see what's going on. What is actually in this container? What is going on in each of these solutions? Well, all of these different ions are in the containers. So when we pour these together, all of these ions are going to start mixing up now. Okay? Before, the potassium and the chromate could only interact with one another. The barium and the nitrate could only interact. Now all of these can interact. So what could happen? What are some possible pairings that we could have here? Well, we could have the potassium go back with the chromate. That could be a thing. The barium could go back with the nitrate. That could be a thing. The barium could go with the chromate. That could be a thing. And the potassium could go with the nitrate. That can be a thing. So now we have some different options of these ions interacting with one another. Okay? So that is going to be what's happening. Next slide. This is kind of a representation of that. We have these two solutions, and remember, in solution here we have barium and a couple nitrates. Here we have two potassiums and a chromate ion there. One thing to be aware of is numbers, right? Whenever we say K2CrO4, that literally means whenever you draw these, if on an exam I'm asking you to draw these things, make sure you have twice the number of potassiums as you do chromates. Same thing, BaNO3 2. There's two nitrates for every one barium. Whenever you draw that, make sure there are twice the number of nitrates as barium. This goes back to kind of the idea of representations of chemical reactions. make sure that in this you represent it appropriately. So what happens? We go through, we take these two things, and we mix them together. Okay, now we have a solution with all of them mixed up. Okay, and what happens? So one thing that's going to happen is that the barium and the chromate are going to start falling out of solution. We're going to start seeing a solid form because barium and chromate is an insoluble salt. These guys, once you have these guys together, the ionic bond between these two are so strong that not even the dipole ion forces can overcome them. So, whenever these two actually meet, they fall out of solution and become a solid again. They can't make this kind of white powder that does not dissolve in water. So that is what's happening in this situation. That's the chemical reaction that's happening. Remember, one of the indicators is that a precipitate is forming. A solid falls out of solution. So that is the chemical reaction here. Now, how are we supposed to know that? How are we supposed to know that barium chromate is insoluble? Why isn't potassium nitrate soluble too? How do we know that? Well, here are some rules. Now, this is a big long list of rules. There are 6 here. There are some exceptions. For the sake of sanity, and quite honestly, the only 2 you can get away with knowing are these first 2. Okay. If the thing is a nitrate, it is soluble in water. If it has a group 1, an alkali metal ion, lithium, sodium, potassium, cesium, rubidium, or an ammonium ion, then they're soluble. So that is these are your 2 rules that we're going to be working with. If I give you one of these guys, I'll go through and let you know, or I'll mention that barium hydroxide is an insoluble salt, something like that. But for the most part, what the things that you're going to be responsible for are that nitrates are soluble and that group 1s and ammonia are soluble. Those are the things that you're going to need to just remember. So for example, let's give you something like sodium sulfate. Sodium sulfate. Right off the bat, you know that this is going to be soluble because it has a group 1 thing in it. Okay, and let's say we have silver nitrate. Silver nitrate, NO3, you know that this is also going to be soluble because nitrates are always soluble. But if I mix these 2 together, silver sulfate doesn't have these 2 rules. At that point, you can just say, silver sulfate's going to be the precipitate because it doesn't fit these rules. Okay. So that is these rules. So let's kind of go back to this. So we can actually now, again, predict what those things are going to be. Again, let's kind of see what your possible combinations are. Potassium can go back with the chromate. No, that's not going to work because potassium is going to make it soluble. Okay. The barium and nitrate can be together. No, that's going to be soluble as well because sodium is going to, or the nitrate is going to make it soluble. The potassium and nitrate can meet up. Well, that's even worse because they both make them soluble. And then the barium and the chromate can come together. This is going to be insoluble. So this is soluble, soluble, and soluble. This is going to be insoluble. This is going to become a solid. Okay. So we have that. So whenever we're actually writing out our products, we can say that barium chromate is going to be a solid. We're going to write that little solid symbol, S in parentheses, underneath chromate when we're writing out our products. And then we're also going to have 2 potassium ions that are aqueous. That's supposed to be a Q. A Q. And then 2 nitrates that are also aqueous. Aqueous. There we go. All right. So this is going to be our products. And we can go through and put that into our complete reaction. Hey, look at that. We have that all done. So this is the complete ionic reaction. This shows everything. But we have a bit of a problem here. In a chemical reaction, we have 2 sides, the products and the reactants, right? Well, if something began as a product and ends up as a reactant, do we really need to show it? I mean, also we got a ton of water over here too on both sides, but we don't show the water, do we? We don't. So we can actually cross out these guys. They don't do anything, right? The nitrates too. We can cross those guys out. They're not doing anything. They're what we call spectator ions. These ions aren't actually part of the reaction. They just were paired with the barium and the chromate before the reaction took place. So yeah, these guys are called spectator ions. Spectator. Because they're watching, they're not actually getting mixed up in the fun bits of the reaction. All right. So there we go. Now, let me kind of keep going. Boop. Here is our net ionic equation. It is, you don't need to include those spectator ions, so it's just barium ions, aqueous, plus chromate ions, aqueous, will turn into barium chromate solid. That is our simplified, pared down net ionic equation. It's called net ionic equation not because it's like we're casting a net, but this comes from like the terms gross and net. You might have heard of gross profit or net profit. Gross profit means how much money you brought in. Net profit is how much money you brought in minus all the money you spent in order to make that profit. So yeah, that's the idea there. Net means that after everything's taken care of. So after I got rid of the spectator ions, this is the net ionic equation. All right, guys, that is the idea behind net ionic equations. The process you're going to want to go through is write things out as their ions. Don't write them out as the aqueous. Write them out as the ions. Then look at your different ions and pair them up. If you see any pair with a nitrate or group 1 or ammonia, that's it's soluble. So you can just say that's still going to be aqueous. It's not going to turn into a solid. If it doesn't have those guys, that means it's going to be insoluble. It's going to turn into a solid. It's going to be turned into a precipitate. All right. Then you can write out that complete reaction with the solid. Remove anything that is on both sides, and now and then pair it down to the net ionic equation. That's the process you're going to want to go through. All right, guys, that's it. I'll probably have an assignment also, so go ahead and do that. Just kind of practicing this skill, going through the whole net ionic equation. All right, guys, have a good one. I will see you guys later.